Hi, my name is Kimberly, and we're going to be going over a previous piece of code I have of mine, and I will be showing you what each thing is and explaining how it works. Okay, so first we have here is a class, and for this class this is our main source. Our main class is going to be our vertex, and with the vertex class, that is what a class is. The class is a user-defined blueprint from which objects can be created. So for with this class, we are creating a vertex, which we need an X and a Y, because we need to be able to find the area and the volume and perimeter of certain objects, and for that we will need to have a vertex for each end of the object. So for here we defined a class, and we defined it as public class vertex, and within that class we have two variables we will be using throughout this class, which is x and y, and they're both doubles. And within this class as well, we have here is our constructor, which is going to be our main constructor that will be used every single time the vertex is called. And what a constructor is, it is a method that is called when an object is being initialized. So this constructor will always be used whenever you create a new vertex. We have two other constructors here. Both of these constructors simply receive the value that will be stored within x and y. Our last constructor here is this is our main constructor, I'm sorry. And these three down here are methods we have. These three methods, as I said before, these two will receive the value stored here. This method here is called distance, and the parameters which it needs are going to be a vertex. And with that vertex, it will give us a distance. So within here, it's simply taking the first and the second vertex. It's going to power them, subtract them, and divide them by 2, and then add them together, which will give you the distance. So what a method is, it is a set code that can be used and called without any pointer of the code. So this distance here will be called throughout every object we create. And vertex, we will use this one in our shape class. Our shape is another class we have here. Here we have an array here. An array is a class stored of objects, which is where the number of vertices will be stored in there to be able to use later. Here we have another constructor. This is where we store the vertice values within the shape we're going to get. Here we have two more methods. This method will simply receive the vertex we amplified, and display info will display the information. So within shape, we have two subclasses that we'll be doing. So we have plain shape. Plain shape is going to be our abstract class, because this class cannot amplify anything in here. We can't edit anything, because an abstract class is a restricted class that we cannot be used to create objects. We need to use, it's a subclass of the main class we have to use, and our main class is our shape. So within our plain shape here, we're going to extend it to shape. That's how we'll be able to create the shape from within a certain plane shape. And we implemented two perimeter measurable and area measurable. Perimeter measurable and area measurable are going to be our interfaces. An interface is similar to a class, but an interface is different in the sense that it has multiple abstract classes into it, and so that's why for our perimeter measurable, we only have our abstract double perimeter, which we can't change from here. It simply is just calling it. And the same for volume measurable. We have our same method of get volume, which we're only calling. We can't implement anything in these interfaces and abstract classes. we can only extend it to our main classes. So for within that, we also have our space shape, and our space shape is another abstract class we have, which extends itself to shape, where we're able to uh, build shapes and store them into our array that we have. As well as plane shape, we have our space shape, which is another abstract class, which we extend to shape, so we're able to create objects and shapes in here. For in the same situation as our plane shape, we have to implement area measurable and volume measurable to be able to uh, use them into shapes, since they are abstract classes and interfaces, we can't modify anything within them. Within this one, we have a constructor as well, which is our space shape. We would just simply take a vertices, and here we have, in this one, it's a super V. This super is an overriding. This is an overloading method that we're using because we take this one from our vertex, which is what simply receives the vertex. So what our super is, we're able to use this within here because we extended all of these within them. V, our vertex is extended to our shape. We were able to use this within our shape. So since plane shape, space shape are abstract classes, we're able to use this super. So we are able to use this as an overloading method, which we can be used and defined and we use over time throughout the code. These codes so far simply receive the vertice and keeps the distance and volume. For within then, we have to go and create our shapes. So for plane shape, we have a circle. We have our circle class here, and for this we have to extend it to plane shape to be able to put it into shape and store that value there. And in this one, we have another constructor here, which is our circle constructor. This defines a circle for whenever you initialize a circle in your main code. So we have another overloading method here, which is our V to get the vertex of each points. Then we have the radius to be able to find the diameter to be able to find the area and the volume and the perimeter for the circle. Here we have methods. We have the same three methods that they be continued on throughout all the plane shape classes. Our main method here is our get perimeter. This does the math to get the perimeter of a circle. So we have 2 pi r, and this will return that value. Then we have another method that's get area. Get area will return the area of a circle. And here in display info, we call the previous methods we have here, and we display it. And then from here in this area, we are labeling the shape, the circle side. Okay, and we're also using this vertex, the vertice here, to print out all the vertices that were implemented in the circle. So this is our circle class. We have another class within our plane shape, and our other class within our plane shape, we have rectangle. So here's our rectangle class that is extended to our plane shape. Again, here we have another constructor, which is the same as previous, which defines a rectangle. We have the same three methods all over again, the perimeter and the area, which will return the perimeter of the rectangle, the area of the rectangle, and then we have the same display info as beforehand, which calls both methods again, prints out the rectangle, and displays the vertex of the rectangle. Another shape we have is our triangle. So here's our triangle class. Again, we have our constructor. We have our same three methods within our class. We have our perimeter, we have our area, and we have our display info. And get perimeter and get area are called again in display info, as well as and all our other ones. And that concludes our plane shape. Now for space shape is going to, okay, space shape is going to do the same exact thing as plane shape, except with space shape, this is where we're getting a 3D vertex. So we have our vertex class for 3D. So in this one, we extended to vertex because it's going to use the same parameters and classes and methods that we have. And this is the construct we have for vertex 3D, and these are the two methods. This method, we don't have to call x and y again. We can use a superclass. We're overriding that from our vertex class, but we do need to have a method to get z to do for the other one for our vertex. And then of course we have distance, which is going to give you the distance of the 3D vertex. Okay, so in space shape, it's going to be the same as our plane shape. We have our constructor here, which which is another overriding here, which would give us a vertex. Within this one, as before, we had circle. Now we have cuboid. The cuboid class is going to extend to space shape because that's where we're able to create the shapes, because we can't use space shape. So here we have our constructs for a cuboid. We have our constructor that will be implemented using the vertex, 3D vertex, and our parameters that we have identified here. And for this one, we have the same three methods as before, except this time we have volume instead of perimeter because it is a 3D shape. So we do the same thing as before. We have the area of a cuboid, we have the volume of a cuboid, and then we have our display where we call the two methods we had beforehand and we return them, and we display all our information. As before, as we had the rectangle, now we have a square pyramid. And the square pyramid is going to be extended to our space shape. We have our two parameters here for the base and the pyramid. For the base of the width, the height of the pyramid. We have our constructor here, which is square pyramid. We overload this method here. That helps us call the vertex that we have from our vertex class. And we have our same three methods, our get volume, get area, and display info, which will call get volume, get area again, and display all the information. As triangle before, we have a sphere. Okay, and for our sphere class, it extends to space shape again. We have our radius to use as another parameter within our sphere. Then we have here, we overload this method again as we implement the radius as well. Then we have our get area and get volume again. And as we have all those classes completed and everything, now we can go to our main class. And within our main class, this is where we'll implement everything that we've done before. This is where we create objects. And so here we have an array. We have our shape array labeled S. And here's where we're going to store 6 objects that we're creating using these other classes we have. So for our first ones, we are going to do our triangles here. These are triangle objects we're creating. And this here is how you implement a new triangle. These are their vertexes. And after we identify a vertex, this is where we identify that the very first item in our array is going to be a triangle. So this is our first object in our array, our very first triangle. Then here is how we're going to implement all the vertex in for a rectangle. And S1 here is going to be our second object within our array. That is going to be our rectangle object we're creating. Then for S2 is our very new circle we're creating, which we use from rectangle. And then we have our 3D vertexes. This is how we're going to create the objects for our square pyramid, our cuboid, and our sphere. So we do the same thing as before. We implemented our vertices and we identify them into each part of the array. So with 3, S3 is going to be our fourth object, which is our square pyramid. S4 is going to be our fifth object, which is our cuboid. S5 is going to be our sixth and final object inside of our array, which is our sphere. So this whole section right here is how we implement objects into our main class. After that, we're going to use a for loop to display all of our information within the classes we created. And so from this, we can simply run our code, and here we go. It shows us our triangle, rectangle, circle, square pyramid, and our cuboid. And it shows us everything we've gone through, from our sphere to our rectangle, our square pyramid, with all the other classes and everything we've done today. So we've gone over class, object, interface, abstract class, constructor, methods, array, overriding, and overloading. Overriding and overloading are very similar, and that is in the case where we have super here and our display info. Our display info, get volume and get area are all overriding from how we use the same code throughout every class we've had.